Hi, this is Al, and I am following up with a video to show you the connection diagram on how to hook up a wind turbine to your home circuits, and then also how to convert it back to down to 12 volts in case somebody wants to purchase one of the turbines that don't come in 12 volts. It's actually rather easy. So I made this diagram that I hope everybody can see well. And essentially it shows my 1 kilowatt Win Max turbine, and the output of that turbine is a three-phase wild AC. It's unregulated. So what you do is you use a UV resistant extension cord that is 3-wire, 10 gauge, and run it from the turbine, which has a connector for the 3 wires to go into, with a strain relief, and then put a circuit breaker, 100 amp circuit breaker through each one of these legs. That gives you three-phase unregulated output to the charge controller that the folks at WinMax packaged together with the unit, which is really a rectifier, a charge controller, and a dump load all in one. So it's a really nice setup, and it is the best bargain that I've seen out there. Unfortunately, I don't have strong enough wind to really use 24 volts. So anyways, the power comes into here, and then from here it leaves as 24 volts DC, and you should go through a 200 amp breaker, or you need to go through a 200 amp breaker, and then go to your battery bank. The batteries or the power from the charge controller always needs to go to the ends, to the extreme ends of the batteries. In other words, if you have more than one battery, then you should go to one positive, which is on one extreme end of the bank, to the negative that is furthest away. And that ensures that all the batteries in the middle are evenly charged. You need to make sure that you understand what kind of wiring to use throughout this circuit, all the way through to the house, by checking wire charts that are available on the internet. And there are also wire size calculators that allow you to figure out how long the wire needs to be run, how many amps it needs to go through, and it will tell you what kind of size wire that you should use. So my picture here shows a set of 4 12-volt batteries connected in series parallel. As you can see, you have 2 banks of 2 batteries. Here is the first bank of batteries that are connected in series. So you have the negative of one battery going to the positive, or the positive of one battery going to the negative of the other one. That makes this connection between this negative and this positive, 24 volts. And then you have another bank of 24 volts made up of 2 12-volt batteries on another series bank, which goes from the negative of this battery to the positive of this other battery, and that makes the connection from this point, this negative, to this positive 24 volts. So notice that now we have 24 volts from here to here, and 24 volts from here to here. So what we want to do is increase the capacity of the system by having the 2 banks connected in parallel, which gives us double the capacity. So we go into parallel connection, which goes from the negative of this battery to the negative of this other battery. So the negative of one bank to the negative of the other bank, and the positive of one bank to the positive of the other bank. Now we have 2 banks of 24 volts connected in parallel. So for example, if this battery was 100 amps, 100 minute reserve capacity, and this one was 100 minute reserve capacity, when you go into a series connection, you double the voltage from 12 to 24. The reserve capacity remains the same. So this bank is a 100 amp bank, just as this one will be another 100 amp bank. So what we do is we connect them in parallel, and the parallel connection leaves the voltage the same. So we have one bank of 24, another one of 24. the total bank voltage is 24. However, the reserve capacity now went from 100 amps in this bank plus 100 amps in this bank is now 200 amps, which is double that capacity. All of the connections should need to go to an earth ground. So all negative connections that you see in this diagram share a common earth ground. It's not a viable alternative to just go into the negative of the battery and everything just connects to the negative of the battery without an earth ground. So from the batteries you go again from the outermost posts through an DC disconnect. And from the DC disconnect, you have 24 volts going to your pure sine wave inverter. The pure sine wave inverter then converts the 24 volt power to AC power 120, 240, which can go to either a manual or an automatic transfer switch, and then from there to your house. The manual transfer switch would avoid the possibility of you trying to feed two circuits or feed one circuit from two different power sources, i.e. the commercial power from the electric company versus your own power. There are other ways to do this, and I will do diagrams showing a grid tie inverter where this is unnecessary. But this is just assuming that you're just gonna, you have a shed or you have a cabin or something of that sort. You just want to dedicate the light circuits in your home for this. There is no reason to go grid tie if you don't want to. You simply have a manual transfer panel that chooses power from either your battery bank and your wind versus the power from the power company. Everything that you see here is for informational purposes only and should not be construed as a document that you could use or a diagram that you can use to do your own wiring. It's just an example. There's no responsibility for your use of the information that's being presented here. Thank you. And have a God-blessed day, and I hope everything that you do works out well for you. Thanks and take care.